Welcome back, students. Today we're going to be talking about the unit circle. So this right here is the unit circle. The unit circle is essentially just a circle that's been drawn on a graph. Now this circle has very specific dimensions. One is, and the most important thing, is that the radius equals 1. Okay, so keep that in mind with everything that we're doing, that the radius of the unit circle is always 1. Aside from that, another thing we want to do is kind of break out the different measurements that are in this. Now, some of the easiest ones for us to do are going to be to first focus in on the degrees. Now, the unit circle is going to start on this x-axis right here. So right at that point, that's our starting point. Now that's 0 degrees. When we do a full circle, if you think of skateboarders, that is doing a full 360 when you've gone all the way around. So we say that going all the way around the circle is a full 360 degrees. Now notice this circle has also been broken up. So back over here, that means we've only gone halfway. So that's 180 degrees. So halfway between 0 and 180, right here in the middle, half of 180 should be a 90. And then if we figure out half of the 90, well, that would be 45. Okay, now from here, I'm going to try to draw a few lines to show how the unit circle is being broken up. So we got that. So there's 45. There's 45 more. And here is 45 more. So 90 plus another 45 would make that 135. Another 45 more brings us to the 180. Another 45 more plus the 180 brings us to 225. Another 45 degrees past that would bring us to 270. Another 45 degrees past that would bring us to 315, and another 45 brings us all the way back to 360. All right, so now we've seen breaking this out by the 45 degrees, but there's still some blanks in there that we're going to need to figure out. So now we're going to break this apart again in a slightly different fashion. Okay, let me fix my 360 now. Okay, so next what we're going to do is notice how this corner right here, that formed a 90-degree angle. And then these two lines right here, chop it into a third. Chop this section into a third. So 1/3 of 90 is 30 degrees. And so each of these lines is counting by 30. So this line right here is 30. So the next line is just 30 more than that, 60. Next line was 30 more than that, which would be 90. 90 plus another 30 is 120. Then 120 plus another 30 degrees is 150. Plus another 30 degrees is the 180 we already know. Plus another 30 degrees and we get 210. Plus another 30 degrees and we get 240. Plus another 30 degrees, and there's the 270 that we had already figured out. Plus another 30 degrees, and we've got 300. Plus another 30 degrees, we've got 330. Plus another 30 degrees, and we are up at 360. All right, so that's it for the degrees. Hopefully you notice how certain lines keep counting by the exact same amount, depending on whether we're dividing things by the 45-degree lines or the 30-60 degree lines. Okay? But if it's just by those 30-degree lines, just count by 30, and you can fill in the unit circle all the way around. If it's by those 45-degree lines, count by 45. So that's counting by degrees. There's another way that we measure our way around the circle, and it's kind of to do with circumference. Now, the circumference of a circle with radius of 1 is 2 pi. Now, this is going to be the measure of the length of the curve that creates the circle. So however long that is, that's what the radian is going to be. So all the way around this is 2 pi. So half of it, notice that thinking, we're just doing the same stuff again. Half of 2 pi would just be a pi. Half of a pi is now going to be pi halves. And then if we take our pi halves and go to that 45-degree line, meaning we're going to divide the pi halves in half again, we would get pi over 4, pi fourths. And now, just like we counted with the degrees, we can count with pi fourths. Okay, so 1 pi fourth, 2 pi fourths. Now 2 fourths is 1/2, which is what it already shows. So 2 pi fourths, 3 pi fourths. 4 pi fourths, which is just 4 over 4 is 1, so we have 1 pi. 4 pi fourths, 5 pi fourths. 5 pi fourths, so this is 6 pi fourths. 6 fourths simplifies into 3 pi halves, which would also coincide if we were counting by just the pi halves. Pi halves, 2 pi half. So 1 pi half, 2 pi half, 3 pi half, and then down at the end 4 pi halves. But let's go ahead and continue counting by our fourths. So that was 5 pi fourths right here, 6 pi fourths, 7 pi fourths, which would end up with 8 pi fourths. 8 fourths would give us a 2. Now remember, these two lines cut the 90-degree into 3 equal sections. So it's going to take the pi halves and divide it into 3 equal sections. So this first one is just going to be a pi sixth. So 1 pi sixth, 2 pi sixths. And then we'd have 3 pi sixths, which simplifies 3 sixths into a 1/2. 3 pi sixths. Then we'll have 4 pi sixths, which would then simplify into 2 pi over 3, 4 pi sixths, and then 5 pi sixths, which would then become 6 pi sixths, which 6 over 6 is just 1, leaving us with the pi. 7 pi sixths, then 8 pi sixths. We're then going to get 4 pi thirds as we simplify it. 8 pi sixths, 9 pi sixths, which would simplify into 3 pi halves. So 9 pi sixths, 10 pi sixths, which would then be 5 pi over 3. 10 pi sixths, 11 pi sixths, and then we end up at 12 pi sixths, which 12 divided by 6 is 2. Okay, so hopefully you noticed how that counting went. If you know that a full circle is 360 degrees, you can figure all the rest out by dividing it into half and dividing things into thirds or even more halves. If you know that the circumference is a 2 pi, you can figure out all the other radian measures in this. So we figured out degrees. We figured out the radian measures. You'll notice we still got blanks of the location, the XY coordinates on this graph for each of those points. Well, some of them are easy because they're already on the X and Y axis. So here we went forward 1 and we didn't go up or down. So 1, 0. Over here, we didn't go forward or backwards, but we did go up 1. Here we went back 1, 0 for Y. And then down here, X was at 0, Y was at -1. Remember, I know these are all 1s because the unit circle has a radius of 1. So if this is the middle of the graph, it went forward 1 and it didn't go up. It went up 1, but it didn't go backwards or forwards. Okay, so that's how I know those. The final ones are probably the trickiest part about what we're going to discuss today. So we need to figure out, how do we know and how can we figure out what these exact XY locations are? In order to do that, we're going to take a look at some common triangles. And we're going to do a bit of a review. We're going to review Pythagorean theorem, just a squared plus b squared equals c squared. And we're going to use Pythagorean theorem to help us figure out those remaining angles that we didn't know. So let's quickly review Pythagorean theorem. Excuse me. So it is a squared plus b squared equals c squared. So in this case, a squared plus b squared is equal to the c squared we don't know. And then we can just begin simplifying. Now, once we know that c squared is equal to a 25, to get rid of that squared, we take the square root of both sides, and c equals 5. So we figured out what that missing side was. Let's go ahead and do that again. So we're going to have a squared plus b squared is equal to c squared. And then if we minus the 25 from both sides, we then get b squared is equal to 144. So we can take the square root of that, and b is equal to 12. Okay, so it doesn't matter which number we're missing, whether we're missing a c, whether we're missing b, or if we're missing a. It's just this same step. If it's the a or the b, notice how we're going to have to subtract that number from both sides. Okay, now here to challenge problems. I would leave those up to you to try to figure out how to do. But let's go ahead and move on. So now let's write an equation that represents the length of a missing side. So notice here in B, they didn't give me a number for it. I still want to write an equation that's there to help me find C. So my ending, because this is the one I'm looking for, C, my ending should look like C equals. That's how we know we've got the equation that finds the missing length. All right, so let's set this up. A squared plus b squared equals c squared. All right, so I'm going to go ahead and simplify that. Final step is I just need to get only c, so I need to take the square root of both sides. So we end up with c equals square root of 9 plus x squared. There's our equation that finds c. All right, here we got another one. This time b is the one we're interested in. So our ending equation should say b equals. So let's go t squared plus, a squared plus the b squared is equal to c squared. All right, now I want to get b alone because I want this equation to say b equals. So I'll minus the t squared from both sides. The 10 squared turns into 100, then minus the t squared. Now we just need to get rid of that square root. So square root of both sides, and we will get b equals, so this will be our answer, 100 minus, or square root of 100 minus t squared. Okay, and that's how we can quickly create these equations, even when there is a variable involved. Now, you might be wondering, where the heck is this teacher going with this? We're talking about circles, now we're focused in on these triangles. The triangles are very important, and your ability to work with these triangles is essential for you to understand the unit circle. The way we're going to figure out those missing parts is by recognizing that we can draw triangles into all of this. So I'll give you an example. One triangle that I could draw would go straight to that 45. So if I'm drawing this right here, now what I have just drawn is a triangle that we already know has a 45-degree angle right here. That's the 45-degree angle. And because I went straight down towards the x-axis, I know I created a 90-degree angle. Now, and then all angles always have to add up to 180, so that last angle also has to be a 45. Okay, so great. I've got this 45, 45, 90. How does that help us? We know these angles. We also know the radius of the unit circle is 1. So what we are going to do is we're going to use these little chunks of information that we can pull from the unit circle, knowing that c in a squared plus b squared equals c squared, that c is a 1, and that because both of these angles are the same, these two sides will also have to be the same. We're going to use that knowledge to then be able to figure out what are these missing values that we don't know yet. Okay, so let's do it with this. We've got a 45, 45, 90. Here's our 90. Because both of these were 45, notice how we labeled both of those sides as x. Okay, they should both come out the same because they were both formed by the same angle. All right, and c is going to be 1 because that is the radius of the unit circle. All right, so a squared plus b squared is equal to c squared. So now we're just going to begin solving this. We want to figure out what x is in particular. So I'll divide by 2 and we get x squared is a half. We can take the square root of both sides and I get this square root of 1/2. Now this right here is an answer and it's an okay answer. We are going to mess around with this a little bit and simplify it and put it in a different form. One rule of simplifying rational numbers is you don't want a radical, the square root, to be in the denominator. So this fraction up here is pretty much the same thing as saying this. Now, luckily, we know what the square root of 1 is. So we just have 1 over square root 2. And I just said we don't like having the square root in a denominator. So the same way that I can take 1/2 and multiply it by 2 over 2 to get 2/4, and 1/2 and 2/4 are the exact same fraction. They're both equal to 0.5. We're going to do that same thing, but with this. Only this time, I'm going to multiply by a square root 2 over 2 to the top and the bottom. So on the top, we'll get square root of 2. On the bottom, that'll yield a square root 4. And a square root 4 is 2. So we know that in this 45, the side lengths are square root 2 over 2, square root 2 over 2. So let's try to look at how that helps us with the unit circle. Okay, so here we go. I've got a unit circle made up here. Notice my angle is a 45, my two side lengths, square root 2 over 2. As I begin to actually, let's just focus in on this first one. Notice what the x and y values would be. We know it goes forward, square root 2 over 2, and then up, square root 2 over 2. So the x value is square root 2 over 2, and the y value is going to be square root 2 over 2. I can also rotate that same triangle and use it in other parts of the unit circle. So if we go 45 degrees past the 90, we now see that it goes backwards, square root 2 over 2, and up, square root 2 over 2. If I go 90 degrees past the 180, we go backwards, square root 2 over 2, and down, square root 2 over 2. We can also get those same numbers there. Now this is going to yield these points where we went forward, square root 2 over 2, and up, square root 2 over 2. Backwards, square root 2 over 2, so a negative, and then up, square root 2 over 2. So let's go ahead and put that into the unit circle. All right, so at the 45, we got square root 2 over 2, square root 2 over 2. Over here, when we went 45 degrees past the 90, that was going backwards, so the x changes to a negative, but we were still going up, so the y stays positive. Then when we went 45 degrees past the 180, let's see, we were going backwards, and we also went down. So both of those are going to be negative. 45 degrees past the 270, and we're going forwards again, so the x will be a positive, but the y will be a negative. And always with just that square root 2 over 2 for each of those locations. All right, so now we've just got a few more. These last ones are going to be formed using a 30, 60, 90 triangle. All right, so the new triangle we're looking at is this one. Okay, so it has a 30 degree right here, a 60, and then that bottom corner is a 90 degree. If we can figure out what these side lengths have to be, if the hypotenuse is a 1, then we've got it. And we'll know how much the x is and how much the y is. So let's go ahead and look at that. In order to create this, what we do is we're starting out with a triangle that is a 60, 60, 60. And then we chopped that 60 in half. So rather than a 60 right there, we now have a 30 on there. So we've got a 30, 60, and also because we chopped it in half here, now a 60, 60, 60 triangle would also have all of its sides being exactly the same length. But we chopped this angle in half, which also created a line that chopped the opposite side in half. So now this is just a 1/2 of x, and that's 1/2 of x. Now x, because we're dealing with the unit circle, we want it to be a 1. So if x is a 1, half of 1 is just going to be half. All right, so let's see. We've got this side is 1, this side is 1, that's a half, and that's a half. So our only missing value is that height. And if we can figure that out, then we've got a triangle that we can then fit to our unit circle. So this triangle right here, where it's a 1/2 and a 1, and we just don't know that, so a squared plus b squared is equal to c squared. All right, if we minus a 1/4 from each side, 1 minus 1/4 is going to leave us with 3/4. We'll take the square root of both sides. Oops. So square root 3 over square root 4, and we end up with a square root 3 over 2. So remember, that's just the h that we had right there. So square root 3 over 2. So here are our dimensions. Notice the longer side is going to be square root 3 over 2. So let's once again come to one of these. Here I've got a 30-degree square root 3 over 2 and up 1/2. So at that 30-degree angle, those would be our coordinates. If we rotate it to 30 degrees past the 90, which would be the 120, notice we've still got our points. This will go up square root 3 over 2 and backwards 1/2. And there we've got our point. Okay, if we go 30 degrees past the 180, so we go backwards square root 3 over 2 and down 1/2, creating that point. And 30 degrees past the 270, we went forward 1/2 and down square root 3 over 2. Now we can use this same one again, but this time rather than making it a 30 degree, this one is a 60 degree. And we went forward 1/2 and up square root 3 over 2. If we rotate it 90 degrees, we get we went backwards square root 3 over 2 and up 1/2. Rotate it another 90 degrees. And we got this one is backwards 1/2 and down square root 3 over 2. Another 90 degrees. And it is down 1/2 and forward square root 3 over 2. So let's come back to our unit circle and we will finish it up. So remember, the long side was square root 3 over 2. So this went forward square root 3 over 2 and up just 1/2. With the 60 degree, our longer side was on the up, so we went up square root 3 over 2 and only forward 1/2. Now also notice how from this point to this point, it's pretty much a mirror. The only switch is that rather than going forward, we went backwards. So my x is a negative, but my y is still positive. And we can do the same with this point right here as it reflects over there. So we'd get a negative square root 3 over 2 and a positive half. We can then also take those same points and reflect them down. So we still went backwards, square root 3 over 2, and we went down 1/2. Negative 1/2, negative square root 3 over 2. Forward 1/2, but still down square root 3 over 2. Forward square root 3 over 2, but down 1/2. And there we go. A completed unit circle with all the explanations as to where our numbers came from. I hope this helps you to understand more in depth the unit circle and where it came from. So good luck.